Good morning. Today I'm going to demonstrate on how to solve an absolute extrema problem. Now, usually when we talk about absolute extremums, it's more or less just a comparison of which one is the smallest value and which one has the largest value over the bounded interval. Now, one thing to consider though is that it is possible that you can have a function of which has a absolute minimum or an absolute maximum if the bounded interval is not given. So like that is, you might have an unrestricted domain such as like all real numbers. So there's actually many different possibilities, but the most traditional one is whenever it's on a bounded interval. So let's try to look at this one where we find the derivative using chain rule and a little bit of product rule. So we'll just put apply product rule and chain rule. Okay. So we're going to do this using product rule and chain rule. So we have f prime of x equals to, well, let's do 2 times x plus 1 multiplied by x minus 3 and squared. Now note that I need to multiply by 1 because the derivative of x plus 1 is just 1. And so if you want to tag that on there, you can. I should have tagged it in the middle, but it's okay. Then we have plus x plus 1 to the second power multiplied by, well, we have that, we can do this where we say times 2 times x minus 3, and then we can put that, that there's going to be a 1 right there. Now, this looks kind of intimidating, but it's not that bad, because in actuality we can just factor as needed. So we have that there's a greatest common factor of a 2, and a 2 over here, but we have that we can take out an x plus 1, and then we can take out an, let's see, we'll take out an x minus 3. Okay, so if we do that, then we're going to have that, that's going to be 2 times x plus 1 multiplied by x minus 3 multiplied by, what gets left behind in the parentheses is that you have an x minus 3 by itself, and then you took out an x plus 1, so that should be x plus 1 that gets left behind in the parentheses. So let's try to simplify this a little bit more. So we have that this will be 2 times x plus 1 multiplied by x minus 3 multiplied by, well, this is going to be 2x minus 2. Okay, now it looks like we have another greatest common factor that we can take out, so that's going to be a 2. So we have that this is going to be, let's write 4 times x plus 1 multiplied by x minus 3. And then we have that that's going to give us x minus 1. Okay, so it looks like we have a few, critical points in this case, because now what we need to do here is go ahead and say that, well, we just need to say that we can set this equal to 0. So, okay, so next we'll just say find the critical points. Okay, so now we'll go ahead and find those critical points by setting this equal to 0. So f prime of x must equal to 0. But if that's the case, then that means that 4 times x plus 1 multiplied by x minus 3 multiplied by x minus 1 is equal to 0. Well, this gives us that we have a set of critical points as follows. We have that there's going to be x equals to negative 1, x equals to 3, and then we also have that x is also going to equal to 1. Okay, so that gives us 3 critical points, but if you notice, only one of these, or one of these will not be used because it's outside the bounded interval that was given. It was from 0 to 4, so in that case, that means that we can't use this one right here. So we won't be using that one. Now, the next step would be to essentially just decide in terms of like which of these is our critical, or like what's the classification, because it did say classify. So in that case, like we're going to have to classify this. Now, we'll just need to go ahead and write somewhere that the original function was, or the prime function was f prime of x equals to 4 times x plus 1 times x minus 3 multiplied by x minus 1. Okay, now this is where we're going to go ahead and apply an interval line test. So what we can do here is set up the interval line, and we're bounded by 0 and by 4. But we have 2 critical points that we need to check, such as 1 and 3. Now, we'll have to plug in some test points, such as like maybe like a half, 2, and then 3.5 perhaps. So let's try this. Well, in class we usually just plug it in to here, and then we just say positive, negative. So it looks like if we plug in a half, it's going to be positive times negative times negative, which is going to be positive. But if we plug in 2, that's going to be positive, positive, negative, positive. So that's going to be negative. And then if we plug in 3.5, well, positive, 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 positive. So it's going to be positive. So that means that at the value of 1, you have that there's a maximum. And then at 3, you have that there's a minimum. I'm going to try to connect this. Okay, so it kind of looks like an S curve in terms of like the graph of the polynomial. Now that we know that 1 and 3 are both minimums and maximums, well, all that we need left to do is to plug in the 0, the 1, the 2, the 0, the 1, the 3, and the 4. So next we just need to find f of 0, f of 1, and f of 3, and then f of 4. Now, let's go ahead and use that the original function was f of x equals to x plus 3 squared times x plus 1, x minus 3. Let's do this. We have x minus 3 squared times x plus 1 to the second power. And if we're unsure about that, we can actually just scroll back up. So x plus 1 squared, x minus 3 squared. Okay, so when we plug in 0, that's just going to be 0 minus 3 squared times 0 plus 1 squared, which is going to give us 9 times 1, which is just going to be 9. Okay, and then we have that f of 1. Well, that is going to be 1 minus 3 squared multiplied by 1 plus 1 squared, and that's going to give us negative 2 squared times 2 squared, which is 4 times 4, which gives us 16. Okay, now I need to find f of 3 and f of 4. Now, interestingly enough, the f of 3 is one of the zeros of the function. So you have that f of 3 is going to be 0, because you have 3 minus 3 squared times 3 plus 1 squared, and, well, that's really just going to give you 0 times that, but that's just going to be 0. Okay, so my last value that I need to check is f of 4. Now, f of 4, if we plug in our value into f, so we have f of 4 equals to 4 minus 3 squared multiplied by 4 plus 1 squared, and it looks like this is going to give me 25 because we have 1 and then we have 5 squared, so that's going to be 25. Okay, so it looks that if we're to go ahead and try to find the absolute min, it's going to be the smallest value on the bounded interval, which in this case is going to be the 0. So we have that this is our absolute min, and we're going to have to look for the absolute max, which it has to be the largest value on the bounded interval, and that's going to be this one right here, the 25. Okay. Now there is a way to check and see like what this looks like. So I'm just going to go here. Here's a graph of the equation that we just looked at. So we have that let's put it right here. We have that the 0,9 is actually nothing. And we have that the 1,16 is also not really much. It's a local max. We have that this is going to be a local max right here. But down over here, we have that that's going to be your absolute min. Now, it should go with saying that the absolute min is also a local min. But then over here, up here at 425, that's where you have the absolute max. So I'll just put absolute max right there. And that's it. So more or less, the process requires you just finding the derivative and finding the critical points. Now, consider this though. If you had a problem of where you were looking at a function, so like perhaps like you had f of x equals to 2x squared. So let's say that you had 2x squared minus 2x. And let's say that the bounded interval is from, let's say like 1 to 4. Well, if I'm going to do this, then that means that f prime of x equals to 2 times 2x minus 2. But that's 4x minus 2. And if I'm going to solve this one for the critical points by setting it equal to 0, I have that 4x minus 2 equals to 0. But that tells me that x is equal to 1/2. But one thing about that is that 1/2 is not in the bounded interval, which means that all that you have left is to check the endpoints. So f of 1 and f of 4. Now, of course, if you plug this in, you're going to get that f of 1 is 0, and you find that f of 4, well, that's going to be 2 times 16 minus 8. So that's going to give you 24. So what that means is that you have that there's a min right there, the absolute min, and then you have the absolute max. So this is an example of when the critical point may not be contained in the bounded interval. And in this case, all that I needed to do was just plug in the values, the endpoints respectively, and then just figure out what that is.